Next, in question 26, we are told that we have two long solenoids, P and Q. Both have the same length. However, Q has twice the radius of P. So let's just write it down. Length of Q is equal to length of P. However, radius of Q is equal to twice the radius of P. The two solenoids are connected in series to a power supply. And because they are connected in series, this immediately means that the current is the same. The magnetic field created by P is in the opposite direction to the magnetic field created by Q. So we are asked what is the ratio of the number of turns of wire on P to the ratio to the number of turns on Q to ensure that the magnetic flux inside P is always going to be 0. So because we want the magnetic flux inside here to be 0, this must mean that the magnetic flux density of P must be equal to the magnetic flux density of Q. For solenoids, we already know from our formula list that the expression for the magnetic flux density in the middle of a solenoid is going to be given by mu naught and I. So let's write it on both sides. Now just take note that N refers to the number of coils per unit length. Which I can further expand to NP over LP times IP. And for the Q side, we have NQ over LQ times IQ. However, the question tells us that since the currents are the same, because they're connected in series, their lengths are the same over here. So LP and LQ also cancel out. And finally, mu naught over here is a constant and therefore it also cancels out. So this means that NP is going to be equal to NQ. And this gives us a ratio of 1:1.